me to understand from Ben Eater's series. Then after that, I'm gonna work on a new page, and there's two very hard challenges that I have to figure out. So I'm probably gonna spend a lot of time thinking. But I had this idea of creating a new page for the website that is gonna be like a good way to work on the things that I think that are gonna be useful, but are not. It's not hard enough, or it's gonna be easier than to create this stuff with the compilers and interpreters because there's still a lot of things that I have to learn. I'm learning assembly and I'm doing a course on how to build an operational system. So, and I'm thinking about several different things at the same time. So there's a lot of stuff to learn still. So I think a good transition would be to work on the stuff that I thought about, which is to just get the Ben Eaters series and then try to create a graph for each component. And then I had this idea that I can compose different graphs together. So for example, I can create a graph that represents an AND gate. And then I can create, inside of the graph, I can put a head node key that is going to point to the node that is going to connect to the other graphs. So I can build all the logic gates separately on their own graphs. And then I can build the other components based on these logic gates, and then do pretty much the same, not the same, but like a similar logic from the way that Turing Complete works, where you're gonna you build the gates first, and then you just create something that represents all the gates you've built so far. So for example, for the registers, I can create a graph that creates the registers from the first one I was thinking about is creating a graph that represents the transistor. Then from the graph that represents the transistor, I create the logic gates. Then from the logic gates, I create the other graphs that represent the higher level structures. Obviously, the graph is always going to be the same because it's just nodes and edges. But then what would change is the label and the color. And as I was thinking about that, I thought that it might be cool, like a very cool thing to do is, like if I'm able to build the whole 8-bit computer that he does, I can run the simulation, like I can run a program in assembly and then I can highlight the nodes as the execution goes. And one thing that would be nice to have is a component that allows you to step forward or backwards in the simulation or to increase or decrease the speed. And also, the challenge with that is that I was also thinking about changing the camera as well, giving the ability for the thing to change the camera, so highlight nodes and edges and move along the graph as it does that. But the issue with that is that like the problem, and this is the biggest problem, and I'm not really sure what I'm gonna do about it, but because like the way that I'm structuring things is that I build the whole graph component and the custom component that exists inside of the graph to work everywhere on the website. So if I wanna add this component, I have to put a bunch of extra logic inside of the thing to handle like the flexibility of what's gonna happen with different types of graph on different pages that I'm gonna create on the website. So like one thing that I thought about is create another component that is gonna just copy and paste pretty much the code that I already have, but then create another structure for the graph and then use that one. And the other approach is just to uh, keep doing the way that I'm doing, just pass more props and then make everything based on the props, which I think is what I'm gonna do. But it's hard because you have to think about all the possible ways that the graph can exist and then how it's gonna change the logic with the props. Because the other thing as well is that depending on the kind of graph that it is better if the other customization component is different because it makes more sense for the other types of graph. So I'm gonna be thinking about this a lot, and I'm gonna try to start today, but I'm not sure how hard it's gonna be. So I might just stop streaming and then think about it off stream. But first, I'm gonna try to explain. Uh,
So ever
it's
since I
about this
upload,
series here. I think I watched a bunch of times. It's the best series on YouTube, without a doubt, that teaches you the hardware components. It's like the best videos I could find. And I had some challenges understanding some key points of this. So I'm just gonna talk about the stuff that I clarified, not about the whole thing. But I'm probably gonna have to go over this as well, like several different times if I'm gonna do this. And this is the thing, like I'm not really sure how hard I'm gonna go with this, because this is another challenge that I'm having, which is to figure out. And it's always like this on the beginning, but I'm very confused, like, because I'm studying compilers, but I'm studying, like, what I want to do is not build a compiler or interpreter. What I want to do is just visualize the code. So because I don't have a lot of knowledge yet, it's very confusing, because like it's not clear how to bridge the gap between the two. First, I have to clarify how the interpreters and compilers work, and then from that point, I have to think about how I'm going to change that structure so that it does what I want it to do. So it's very hard to learn based on that. And I think that doing this is going to be very hard as well. So if it's just like too hard, then I think I'm not going to do it to the end. I'm just going to build some of them. And then the I'm going to stop and then try to work on the other stuff. I think the main value of doing this now is to improve the way that visualization is going to work, and to actually have something that is useful. So yeah. So this is the page that I have so far. The other thing that I also struggle a lot to think about is like how to make this look better, because it's very hard. I don't want to spend a bunch of time on CSS, obviously, and it's very hard to think about what things I can put here to make it look like. I think I can see like on a website if it looks good or not, but to think about what kind of stuff you have to put is very hard, because I think that most of the things that are on the pages is going to require a lot of effort, and I think it misses the point if I spend a bunch of time trying to focus on that. So like I can create animations for this, and I can create like 3GS visualizations and put icons and stuff like that, but it's just going to remove all the energy that I'm going to spend, that I would be spending doing the thing that matters, which is like improving the visualization. So I don't want to do that. So I think I'm going to leave like that as like minimalistic as possible, I think. And hopefully it doesn't, maybe I'll think about this like later, a lot later on. So, but the idea that I have is just to explain here what's the, like what the cards are about, which is from the series, Ben Eater's series. And then here I'm gonna have a bunch of cards that have this like visualizations. And the other thing that I was thinking about is that I want to connect the navigation of the graph with the navigation of the website itself. So each, which is going to be very hard to do as well. So I have to think about a way to make the label work as a link. So when you click the label, and this made me think, which is the other hard problem that I have, which is how do I handle the events? I think I thought about that when I was creating the events, the drag event in the first time, but I was focusing on other stuff. So the challenge with that is that for each graph, the event's gonna change. So I think I can't create the events inside of the graph component. I have to pass it as props. And both with the animation as well, I have to pass as props, I think. And I think the best way to pass is through a function, because for each thing is gonna be very like specific what's gonna happen. So the way I was thinking about doing the animation is just passing the path of the nodes that I'm gonna highlight. But then I think that is not very good, because it might change. So like the logic that I'm gonna have to put inside of the component is gonna be like static. It's just gonna be one, and it has to work for every single possible thing. So I think it doesn't work very well. I think it's better if I just pass as a function, and then I always pass the same arguments to the function, and then I have flexibility to do whatever I want inside of the function. I think I'm gonna put some epic music. I'm not sure what volume to put this music at. I listened to the previous streams that I did, and it's kind of hard because it depends on the music. So I don't want to put it too high so that it messes up it becomes like very bad to listen to what I'm saying. So I'm gonna read. These are the notes that I took. I'm gonna read this and talk about. I also did a course where he creates a compiler in C. So I might look at that later on as well and try to translate to Python. But he doesn't talk about grammar and all this stuff. He's just like, maybe is because he divided the course. I only had access to the module 1, and I think there's 4 modules, so maybe he talks about that later on. But for the Lexer and the parser, he just explains the way that he does it is just creating flag variables and then pattern matching on the specific things. And with the flag variables and the pattern matching, he separates the logic of what's gonna happen once you encounter that thing. Wait, binary counter is made out of 4 master JK slaves. Master JK slaves made out of 2 SR latches. Each master JK divides by time by 2. That's how it counts in binary. It is based on the clock cycle. So the binary counter that is used on the program counter is just this circuit here, where it connects the main clock with these logic gates, and that each time that it connects the clock with this logic gates is going to divide time by 2 because of the way that the logic gates work. And this makes it count in binary because each one of the outputs represents time in binary, a number in binary. So registers have load and enable circuits, tri-state. They only store the bits that will be used for instructions or calculations. So the way that it works is that everything that happens on the computer is through registers, and registers are like the fastest memory accessible to the computer, and everything is connected to the bus. So the problem with that is that when you have information passing through the bus, because it's all circuits and voltage, if you don't have like some logic that disconnects the register from the bus, what happens is that you're gonna set the state in like it's gonna mess up the state, because every time that you have one bit going to the bus, is gonna set the bit on every register, and obviously that's not what you want. So you have to create these 2 different circuits which are based on tri-states, which is a logic gate, and this allows the registers to enable and disable. So you have the load, which is the state that is going to load the information coming from the bus into the register, and you have the enable, which is the one that sends the information from the register to the bus again. And the main part that I'm going to talk more about this, I think, later on here, but the main part that I was confused about is the central processing unit, the CPU, which I think in the series is just control logic, so it's a simplified version of the CPU, because the CPU has 4 different control logics, I think, or it depends on the CPU and as many threads it has. But the way that it works is just another logic gate that is going to be connected to every part of the computer, and that logic gate is going to be the one that determines at which point each one is accessed. So the logic gate, the control logic, is the thing that is going to determine when the register is loading or storing, or when it's disconnected from the bus. RAM is made out of several different registers and a logic circuit that determines the address. So a RAM is just a bunch of registers, and the reason why it's random access is because you have to refresh the memory at each time interval. I forgot the time specifics, but if you don't refresh, because it's made out of capacitors, the capacitor loses its charge and then you lose the data. So you have to keep refreshing the memory at each time interval. And it's just a bunch of different registers on a row, and that creates what creates the address in the RAM is another register. So you have a register connected to the RAM, and the register determines the address. It is like a mapping of the address with the data. So you can imagine that, and the difference between them is only the names, like the concepts, because in binaries everything is the same. So the register is just a collection of bits that determines at which row of the registers you're gonna have some data. So the address is just the rows of the RAM, and the data is just the register that is from that row. So it's just a collection of rows that has a bunch of registers. The registers contain the data, and the row is the address. Jump instruction is just setting a new address in the program counter. This will make it go to the address instead of going to the next thing in memory in the next clock cycle. So The jump instruction is based on another register, which is connected to the ALU, which is the arithmetic logic unit, which does the calculations. So the ALU is connected to other registers. This register sends the bits to the ALU. The ALU calculates, so either sums or subtracts the number, and it does that based on a true complement system, which is a binary system that allows you to have positive and negative numbers and also to sum and subtract them. And division is based on the rotation, it's just a shift of bits. So, and it's shift of bits and subtraction. I think I wrote down some stuff here, which is also confusing, and I'm probably gonna have to review that, but it's not that important, so. But everything is just pretty much based on subtraction and addition. And then whatever the result of the calculation is gonna be, then you can create another register that is connected with the program counter, which is gonna signal what the result of the calculation is, and then depending on what kind of jump instruction you have, you're gonna have different conditions for when the jump is gonna happen. So you can have an instruction that is jump 0, for example. So when the sum or the subtraction is equal to 0, it signals to the program counter that is 0, and then instead of going to the next address, the program counter goes to whatever label the jump instruction has. The other jump instruction is the carry one, which is another register that determines a carry, and then based on the carry is gonna jump or not. But it's pretty much just based on the calculation. And jumps, like the name says, is supposed to, instead of going through with the address sequentially, as the program counter does, it just goes to the one that is instructed that they're on the jump. Turing complete requires conditional jump along with basic calculus operations. A normal jump. So a Turing complete machine is just one that has is like an infinite tape, and then as if you have a pointer on the tape, and then you can go anywhere on the tape. And I think you can do branching as well. It's branching and jumping. Those are the conditions, I think, for having a Turing complete. So you can decide what you're gonna do based on the input, or you can jump around based on the input. But it's also not that important, I think, because it's just a definition thing. It's important in the sense that, like, for communication and stuff like that, but not in the fundamental principles, I think. Fetch cycle, counter out, memory address, registering, one clock cycle. So this is so every instruction is broken down into micro instructions, and each micro instruction is an OP code. So the way you program the instructions is just by setting on the control logic what's gonna happen. So remember that the control logic is the thing that is connected to every component of the computer. So, and in the series it's kind of confusing still, because it's missing the part which is the BIOS setup and the operational system. So because obviously he can't like build everything, so like he's building a simplistic version. So there's still some stuff missing, and that's why it's kind of hard to understand. But it's pretty much, he manually programs, like he puts the program counter at step 1, for example, and then he manually sets what's gonna happen, like which flags are gonna be 1 in the control logic, and then based on the settings that are gonna be 1 on the control logic when the program counter is 1, that's how the information is gonna flow. So the way that he does it is just counter out, memory address register in. So he takes the data from the program counter and passes to the address register in one clock cycle, then RAM out, instruction register in. Then counter enable to increment counter. And this is like the micro codes, when you put together, this is gonna be one instruction, and that's the fetch cycle, which gets the data from the program counter and passes to the RAM, I think. And then he does that a bunch of times so that he decides what's gonna happen, like for each instruction of the thing. So it's like building an instruction in assembly with binary. So you decide on the control logic what's gonna happen when uh, the thing is that I have to explain other stuff to explain this. So, but pretty much he programs the hacks, and then based on the hacks, which is the instruction, he programs manually this stuff with the control logic. So what's gonna happen whenever you have that input, that is gonna be the data that you set, which is the command. So the command is just the data. And in the series he manually programs, but the way that it works in reality, which I think, obviously I still have to study this, but the way that I believe it works is that there is a standard for creating a BIOS, which is the first setup of the computer, and that's directly programmed on the hardware. So it's pretty much the way that he does it, but far more complicated, like it's far more structures, far more instructions that run every time that the computer is loaded, and the BIOS is stored on a small battery. So from the BIOS you have like the first interface, and then that's where the operational system is gonna be programmed from. So everything is built on the hardware in the first instructions, which is just setting the data and then setting what's gonna happen after that data is sent, and that creates a bunch of instructions. So yeah, not sure if that's clear or not, because it is kind of confusing to understand in the first place. The first time that the data becomes the program, like the commands, is very hard to understand. But I think I have a very good grasp now of how it works. The memory address register makes the RAM have the data for that current address. So when the counter goes to the bus, the address that was on the counter goes to the memory address register, and that makes it automatically load the data, which is the made-up instruction for the command that was built. The video is LDA or load, and he decides what it means, because the memory address register is a register that maps addresses to the data that exists for that address in the RAM. He gets another binary counter in order to sync it with the micro commands he wants at that time on the counter. So time 0, which would be first instruction, he puts T0 counter out, memory address register in, then hooks up the input of that binary counter 0 to the control logic setting counter and memory address register to fire off when the binary counter is at T0. Connects two EPROMs to control logic, programs EPROMs with logic for which micro commands to trigger at each time step. So this is another part that it's not that it was hard to understand, it's just that like there's so much stuff here and there was so much other stuff to learn. So like this is what makes it hard in the beginning. But now, and this is like this part here. So first he talks about the ALU. Like he builds everything from like explains the gates first, the clock, then talks about the ALU, the register, then this master slave. So the master slave JK flip-flop is kind of like a memory cell and works based on the clock cycle. So it just holds the state of the data. So it's either going to be 1 or 0. And that's what makes it possible to have the other stuff. I don't remember really well if the master JK slave is the one used on the RAM, or like it's all based on the same stuff, but there is some variations. So like the SR latch is the one that I remember that sets the memory like manually, and then you have variations of that sets based on the clock cycle. Yeah, then he talks about the program counter, and this is the part of the 7-segment hex decoder. So a hex decoder pretty much is just combinatorial logic, and combinatorial logic is just when you decide like what's gonna be the inputs of 0s and 1s, and then based on that input you highlight a cell on the hex decoder thing. So based on that, you can decide which cells are going to highlight based on which kind of inputs, and that creates a number visually on the LED thing that he has, and that's the hex decoder. So you're just arbitrarily creating an image based on the zeros and ones, and that image is going to represent a number. So for example, 2 is going to be several different segments together, and each one is turned on or off based on the zeros and ones. And then that's what creates the hexacoder. But because the logic is complex to create all the impulses that are going to build the number, what he does is just he gets this EEPROM, which is this thing that is a logic. It is the connection of all these logic gates that is going to allow you to program these digits. So you don't have to put the logic gates together, you just get this other circuit that is built for that. And this is the stuff that he uses to program the commands. So he programs that outside using an Arduino, programs all the instructions there, and then based on that, it runs the instructions on the computer. And this is why it's kind of hard to understand this part, because obviously he uses the Arduino instead of creating everything with the hardware, which is understandable, obviously, but it's just combinatorial logic. So it's like, you can think about it as a preset state of zeros and ones that's gonna happen on the EEPROM. And then based on these preset states, the program counter is gonna fetch that from the EEPROM, and then send to the register, which is gonna send to RAM and store the data based on the address. And then on the other clock cycle, if you have another command that you want to program, so what you're doing is pretty much just syncing the state of the EEPROM with the components of the computer, and that allows you to programmatically determine what's going to happen based on a sequence of binaries. And I think the main thing that I got away from this, which was very confusing for me on the beginning, once I started learning how to code, is that there isn't anything like that is fundamental, like there isn't any fundamental principle that is going to determine what is a command on the hardware. Like this jump from the binaries to the hexacoder is just arbitrary. So like we are creating what is going to mean for the computer to have those inputs, but the computer doesn't understand like what is true and what is for and stuff like that. It only understands the inputs. And the reason why it's possible to build an information system based on that is that the pixels on the screen are going to be based on whatever the state of the binaries is. And obviously it's like extremely complex on the hardware we have today, because the fundamentals stay the same, but it scales much more, and there's billions of transistors and like a bunch of other stuff, but it's just pretty much more of the same thing, and it just allows you to store more memory. And then the way that it happens is that because that information is going to determine the calculation of the pixels, then you can encode the information and you can decide what's going to show up on the screen. But from the computer's perspective, it doesn't understand what is calculating. It's just a bunch of impulses. So you can think about the computing as human beings projecting an informational system that maybe it's not projection. In one way to think about it, it is fundamental because it's part of the laws of physics. So like we are capturing something fundamental about the universe that allows us to structure the electromagnetic field in a certain way that is gonna show up images on the screen. Yeah, so I think that's pretty much what's happening. Like you're manipulating the electromagnetic field based on the zeros and ones. And the reason why it's capable of showing what's showing is because what is showing is a projection of imagination, I think. Because it's just a collection of zeros and ones that is based on the symbolic meaning that we create to coordinate on space-time. So the information that we are encoding into the numbers is the projection of how we structure that information in our minds. So in one way, it doesn't have any meaning on the computer because we arbitrarily decide what's going to be the command, and also the same for strings. But in another way, it does have the meaning because it works. It's just so every at the base layer, everything is a data structure. So the other channel that is very good to and helped me a lot as well to understand like the more advanced stuff that exists nowadays is Branch Education. Is extremely good, and a lot of these videos I watched a bunch of times as well. So, but it's pretty much more of the same thing, and it's just a lot more complex because then they automate the process of designing the chips and creates a lot more. And then there's the Moore's law, however you say the name of the guy. That's the transistor keeps the size keeps decreasing, and that allows you to have more and more complex gates that is gonna store information of the electromagnetic field, which is pretty crazy to think about. Like the more I study about this stuff, the more like it's insane. I realize how insane it is that anything works at all, because it's so crazy, and everything depends on the clock cycle, which is kind of insane if you think about it. And this is something that I was studying as well the other day, which is that it seems like theta waves in the brain have like a very similar purpose that clock cycle has in the computer, which is to synchronize everything. So I think that theta waves in the brain are analogous to the clock cycle, and the clock cycle is going to determine what, like the frequency of computation, because it determines what like all the other instructions and how the components are going to be synchronized. Just really trippy to think about. Conditional jump, arbitrary like the other commands, is based on the operation from registers. Ben selects either based on sum equals 0 or carry. Register. Tri-state allows output to only be connected to the bus when it makes sense. It creates an enabler that determines whether or not output is going to work. This allows the load and enable for the registers. So the main thing that like the way I'm think about it now is that pretty much everything is a register for controlling like logic like that, and how everything is connected. And then for things that require more memory, you use the RAM. So logic is the way that the computer communicates with itself, and then the RAM is like higher. It takes more space, but is lower. So the main thing is the RAM and the registers and the control logic and the ALU. So those are the key components, and the program counter, which is going to determine what's going to happen at each time. So you can think about the control logic as being the brain of the computer, because it decides what's going to happen. Not sure if that's a good analogy, because obviously there's a lot of differences there. But maybe it is, actually. And the program counter would be like the heart. No, the clock would be the heart. I'm not sure what the analogy is there, but... And EEPROM truth table builds hexadecoder, division binary. So you rotate left and subtract. This one was kind of hard for me to understand. I'm still a little bit confused about, because I couldn't understand this explanation very well. But he pretty much creates something that rotates the bits to the left, and then up until it gets to the size of 10 in binary, which is 10, 10. 1, 0, 1, 0 is 10 in binary, and then once he gets to that size, he divides that, he subtracts that. So he's getting the remainder of the division by 10 each time. And the remainder of the division by 10 is going to be the digit of each thing. And that's how you convert the... this is actually not division in binary. This is how you convert the binary into decimal. But I think after that he explains, like he uses that to divide. But yeah. Or maybe I'm confusing. I think that the division is just rotating to the left and subtracting. Yeah, that's dividing. And then, so you're pretty much dividing by 10 and getting the remainder. And the divisions rotate by to the left, the bits to the left, and then you subtract. And you do that over and over again. And then you have the digits of the number, and based on the digits, you get the decimal value. And the first data structure he talks about is the stack. Obviously, there is the other ones first, which is the... I'm not sure. Floats would be decimals, I think. Obviously, it's going to be different because you have the points. And yeah, but the first main one that he talks about is the stack, and which is just a pointer to the RAM. And then, based on the stack, everything else is going to be built, I think. And I think array is the first, because array is just the sequence of addresses, I think, in memory. And then stack is when you use the pointer to determine what's going to happen on the... But I don't remember really well this part here. I'll be right back. So hopefully it's clear. Like it's a lot of information. I think this part of the stack here is from another series from the other playlist. So this is like the beginning one, and then he has another one which is for like a more advanced computer. But for this other one, he doesn't start like he's more programming directly on the Arduino, I think, or on the computer with assembly instructions, which is understandable because on the other one he goes up to the point where he creates the assembly instructions from binary. So now I think I understand. So the main fundamental commands that exist that I understand for now is the if-else statement, which is just gonna be based on the result of the ALU, I think, and the jump instructions. And then so it's pretty much everything is based on that. And with the jump, you create loops and you create scope. The stack is the thing that creates the scope, I think. And the stack is just a pointer to the memory, but it's gonna be based on jump instructions. So everything else comes out of those, I think. It's just a variation of those, which makes a lot of sense.
Well, it seems like
Because I think that this is how the universe works as well. It's just a multifractal pattern, and it's based on the laws of physics. But I think that is an infinite spectrum of causality. So one frequency of awareness creates the space-time, which is a multifractal, which is going to contain like the fundamental rule set from which everything else is going to exist. So it's very basic rules that create very complex behavior, because out of the basic rules everything interacts. It's kind of like the game of life, which is computationally reducible by definition, because space-time is just the reduction of infinity under a computational length. So it's on this one that he talks about the stack, and I don't remember really well. Like I'm gonna have to watch these videos again, I think. But there's so much stuff to study, it's kind of hard. Yeah, and this graph here, I'm not really sure how far I'm gonna go with this one. I think it might be better to try to build this stuff first, then I go back to this. Because now I think I can create some connections here, but like the thing that I'm thinking about, which is the stuff that I said in the beginning of today's stream, is that like what I'm trying to do is not, I want to be careful to not lose track of what I'm trying to do, which is just visualize the information. Which is different than building the interpreter or compiler. So like my concern is that if I build this, I'm gonna spend too much time doing the thing that doesn't matter, instead of doing the stuff that I actually need to do. So I'm not really sure about it. And now, like the main question that I had was that in the beginning, I think now is more clear on my mind. Like the bridge between the instructions and the data structure is the assembly, low level, and the way that it works is based on the EPROMs. Or read-only memory. I think in real computers it's just read-only memory, but it's another variation of a EPROM, you can think about it. And everything starts on the BIOS, which is just like a standard that predefines the beginning interface that the computer is going to have, which comes from the hardware directly. And then the operational system is going to be, you're going to create the bootloader, which is going to have the initial instructions, and then based on that you're going to create all the logic that creates the file system and that handles the execution of each thing, and that handles the security aspect, which is at which point we have access to memory. And then the other name for that is kernel, so which is another keyword to know about, to search, because there's a lot more videos about kernels, I think, than operational systems. I think the videos about kernel tend to be better than the videos about operational systems. Yeah, so it's like data structures all the way down. I think what might be better to do is just to go over the source code for the C compiler course. and then see how there is a segment there that he does the scope, which, and also I think that he separates the data that for each thing on struct, and then so each thing that he parses, each lexer that he parses is gonna have a bunch of data, and that based on that data it says what's the scope of that thing and what's the parent scope. And then he speaks about in some parts that you shouldn't try to keep the scope as a tree because it's not very efficient, and it's better to just keep the scope of the parent. But there is some stuff about variables and scope there in the thing that I saw. So I think what I might try to do is just try to go over that source code and try to translate into Python for what I'm trying to do. Yeah, but now what I think I'm going to do is spend some time thinking about this. So this is the stuff that I wrote that I have to do now, to follow. So the routing I saw, you just put the 2 dots before the name, and then you create the new page, and then you can get the information from use params from the React Router DOM on the page. Is this one? So yeah, whatever I put here, whatever name I put here, which is gonna be the name of the component that creates the card from this page, which is this page here. Whatever name, I pass the name from this structure here, and here, like I'm gonna put the name of the graph. So I'm gonna create a file, a folder here that is gonna contain, oh, I already created. So I'm gonna put this, I think I'm gonna do a bunch of JSON, and then to get access to the JSON file, or I can do it with the, oh no, I forgot the dots. And then I can do a fetch request to get the file. So I'm putting a name in the description, then I pass to this card here, which is this component. And then this is gonna be the link for the page. And then whatever name I put here is gonna be the name that is on the route here after this. This thing here is just the space, and it doesn't matter for when you use params. And then when I use params, I'm gonna have access to that, to this part here. So based on this, my idea is to create a dictionary that contains the name of the thing as a key, and the value is going to be the graph loaded from this hardware, this page here, which is going to contain the graphs for each thing. So I think this is the first thing that I'm going to do. Then I have to think about how I'm going to create the components, which is the hardest part. This is already tested as well, because this is another thing that I was thinking about, is how to pass the data for the animations. I think I decided that I'm gonna just make attributes on the nodes and edges. So like one problem that I think I'm gonna have to see how I'm gonna make that happen as well. But the problem is that for the animation, like the way that I'm thinking about doing is just changing the color of the edge and the node at each step of the animation. So one problem is gonna be, how do I make sure that the animation goes at a pace that makes sense and doesn't go like extremely fast. Because if I just put on inside of the use frame, it's gonna go with the same velocity that the other stuff goes, so you're not gonna be able to see what's happening. But the idea is to change the color in the nodes for each step of the thing. But the problem is, like, I was envisioning in my mind like a neuron firing the brain, where you have like this impulse and then it changes the color of each thing as the thing is executing. But the issue with that is that I have to revert the nodes back to the old color after the wave passed through them. That makes sense? So I was thinking like how I'm gonna hold the states and how I'm gonna translate that. I still have to think about that as well. But the way that I decided that makes more sense is just to put a different attribute on the node and on the edge for the new color. And then I just create the function that I'm going to pass as props to the component, and then inside of the function I decide how the update is going to happen. But the issue with that is that I wasn't sure if you just changing the color of the node directly would make the graph reload each time, which wouldn't be very good. And the way that I think it works right now is that if you change the color directly on the mesh, it doesn't make React re-render the components, which is a lot better, so it's faster. So I don't have to renew the nodes and edges each time. I can just change the same object each time. And I wasn't sure if that was the case, but now I tested this and it seems like it works. And the next thing is to create the ability for the node and label, for creating the label into a link. And this goes back to the eventing of how to structure the event in a way that makes sense. And I think what I'm gonna have to end up doing is just create an event for each thing. Like for instead of creating, but it's a problem because I can't create the event directly on the. Yeah, so what I was thinking about doing is just grabbing, instead of grabbing the way that I'm doing there, where I'm grabbing the groups for the nodes, I grab each mesh separately, and then based on the meshes I do the logic. And then I pass the functions as props to the thing. So let me show. Is here. Yeah, so right now that's how I'm doing. I just put the event here and then the functions here. So instead of doing that, I'm thinking, and then inside of this function, I use this found here, which intersects this group. So instead of doing like this, I think I'm gonna create 3 different ones of this, and then I'm gonna pass as arguments to the function. And then I'm gonna receive, instead of creating the function here, I receive this function as props, because then it allows me to create the logic for this function outside of the components. Because the problem is that they're gonna change each time. So, like I was thinking about, in some situations, instead of, for example, the node, instead of dragging the node when you select, I could create something that when you click the node, it goes to another page, something like that. But it's a tricky thing because then it disables the drag functionality, so. And this is what I mean, that this is the reason why it's very hard, because then I have to think about the whole design of the whole thing. Because what I can do is just create another variable in the store that's gonna determine like what's gonna happen, if it's gonna drag or create links. But then it complicates things even more, so. But I think separating them makes sense, and then I put the this function, the arguments that I pass are gonna have to, so instead of doing like this, I was gonna do it like this, and then I pass, so whatever arguments I decide to pass here, like the first one is gonna be the event, are gonna determine how I'm gonna structure this function here. So these like arguments are gonna serve as a template for all the possible functions that I can have. And then for each situation that I wanna modify or that I wanna change, I will do a different thing. But I think I need to focus on the animation first. So one question is, how do I structure the nodes? It should be a string, I think. I'm gonna have to, because obviously I don't know the specifics of each thing. Like I know that obviously the AND gate's gonna be, maybe not obviously, but 3 transistors, and then based on the 2 different ones, I can create the logic, the truth table there's gonna be. So, now obviously when they're both on the, but this is the stuff that is hard because the way that I was thinking about is, like I'm gonna represent them as off when they are red, and as on when they are green. So the question is, how do I make the animation? Because it would be good if they could click the thing and then turn the node on to see what happens. And then I can compose the more complex graphs based on the simple ones. Yes. Is that better? Someone's asking to increase the font size. More? The problem with increasing the font size too much is that it becomes very hard to program, because I don't have a lot of space then. I don't know why. I think there's something I need to put in a different format because it's JSON, so. Don't know why it's like this. What do you want to know specifically? It's gonna be very hard to explain everything, but like if you have, you can obviously try. Oh, I think it's because of the way that I'm doing the things here. It has to be this one in JSON. So I think I'm gonna build. I also have to remember that I have to do. This is gonna be. I think I'm gonna do it outside, so it's not. So I can keep the node's data structure the same. So I put node head here, and this is gonna be the node that connects the different graphs together. So I have to think about the idea is always gonna be. I think it's better to put it as a number instead of a string. But then the problem is, I guess I put here as a number as well. And the ID is always going to be unique, I think. And the other thing you have to see, like, I think the arrows are fine now. I think that the way that I did the arrows works. The only thing I have to do is just change, because now I find a way to rotate the labels as well in the way that makes sense. So it just rotates based on the camera. The camera rotates, it just updates the rotation of each label based on the rotation of the camera. So I can do the same thing for the arrows, but the way that the arrows look wasn't very good. So I have to see. But I think a good idea would be to just put another option and then allow to put the edges or not, and then make the default without edges. I think that would be a good thing to do. So, okay, let me try to explain. What I'm trying to do is just to. So someone asked, what is the project? So. What I'm trying to do is create a funnel that turns code into visualizations. And the reason why I'm trying to do that is so it becomes easier to understand what is happening on a complex software. So I think the Ethereum one is probably the best one for this. Because I'm self-taught, and like the hardest challenge that I had so far when studying projects is like pick up, imagine a project like this. So like the way that I always try to learn these projects is just by going to the GitHub. Then you see like this massive files here and like everything, and then you read the documentation here, and then you like get a sense for what the software is about and how to initialize things. And then what I would do is just look at this thing here, and then I would look at the entry point of the thing. So I would try to see what commands they are running, and then based on these commands, I would try to find these commands on the files. And then based on whatever command I find, I search for the file that has the command. So obviously this is not the case, but just for example, let's say that I figure out that the first command that runs is this in this file. So I would go to this file, and then I will look at the command, and then I would see what the command is doing. So like if it's a function, what variables is changing, what variables is calling, what other functions is calling, what other files it's calling. And then based on these entry points, I would go back and forth between files, trying to understand how everything is connected and how everything works. But obviously this is very inefficient, and like since I started learning how to code, I always had this idea. Like the first was very in the beginning when I was learning, that I was trying to find a website that allows you to connect, like to visualize the connections of everything at the same time, because it's much easier to see how everything's connected if you have a graph visualization instead of going file to file, because then going back and forth is a lot easier. It's like a bird's eye view. But then I couldn't find anything. The closest thing that I found was Python tutor, but it's not exactly the thing that I was thinking about. So now I'm trying to build that. But it's extremely difficult, and I'm not pretty sure. I'm pretty happy already with the progress that I made, but not 100% sure how far I'm gonna be able to go, because it's very hard. So, and here you just put the code here, for example. And then you visualize execution, and then it shows you what happens each step. But the thing that I'm trying to do is more like visualizing like this on 3D. And then if I press the arrow keys, I can go back and forth on the nodes. And here I can change the physics as well. Oh, the other thing that I didn't talk about, that I changed from last time, is that there was too many options here, so I decided to do like this, where I change here, and that gives me a lot more space. And now what I'm trying to do is just to, as like the beginning of this, is to create a bunch of graphs that have logic gates. So I think I'm gonna start with the AND gate, and then each graph is gonna represent how the logic gate works. Maybe I should start with the transistor first. Like, I start with the transistor, then I create the logic gates, and then each graph is gonna compose the other one. So the first one is the transistor, then I use the transistor graph to create the AND gate logic based on the connection of the nodes, of the edges. Then based on that, I create... But the thing that I'm not really sure is that I was thinking about... Like, because it would be better to give the option, because if you do everything with the transistors, it's going to be too complex in the end. So it would be nice to also allow the option to simplify. So instead of showing the AND gate as a collection of transistors, it just shows the AND gate as its own graph. And then I simplify like that, like building on the concepts. And then I put all the graphs together, and then I allow the possibility to visualize what's happening on the computer by changing the highlight of the nodes. So they all start red, for example, to signal that they are all 0. And then I display like what's happening when they turn on, which will be the green light. And then I change the edge. And this will allow me to visualize like the execution of the binary instructions in the computer to understand like how it works. It's much easier to see how it works. And like there's several different ideas that I have, but there's a lot of stuff to do before, so. But I am pretty happy with the stuff that I got already. I guess this is one of the things that I have to think about first. So how I'm going to structure this. I think it's probably better to just structure, like I create the, like it's going to be better from the visualization standpoint to just create the, so I create the transistor logic gate first, like the transistor graph first, which I think is just going to be 3 nodes to represent the gate. So the middle node is going to be silicon, or I forgot which exactly are the chemicals, so I'm gonna search now. But then obviously they are connected with the other ones, and then based on the voltage is gonna change the chemical properties of the thing, which is gonna allow the voltage to pass through. It's gonna turn on the transistor. So I think obviously it's gonna be simplified. So the other thing that I was thinking about is just including sprites, which allows you to include images as well, which I might do in the future, but it's too hard, I think, because there's still a lot of other stuff that I have to do. So I think for now I'm just gonna make a simple graph that has the 3 nodes connected, and then it's gonna highlight. I have to think about how I'm gonna like represent a high voltage or low voltage. Maybe I can create an input that represents the voltage. But then like this is the stuff that it is complicated, because if I create an input that represents the voltage, I'm gonna have to change the way that the graph works. I think this is one of the fundamental problems that I have now, is like how do I decide how to structure the graph, because I'm using the same component for each part of the visualization, and there are going to be several different visualizations. So the more the more differences in visualization I have, the more props I have to pass to the component in order to customize the behavior of the graph. And which components are going to show and not, which customization components are going to show and not show, and what they're going to have. So maybe it's better to put head nodes. Oh, the other thing that I was thinking that would be nice is to have a label for the edge as well. In the middle of the edge, I think that's gonna be... I thought about this because of the bus. I think that's gonna be nice for the bus. But again, it's very complicated because then I have to add the label mesh for the edge, and then it's gonna change like all the other stuff as well for redrawing everything. But I think if I make the position dependent on the edge, the edge mesh, then if I change the edge mesh, it's gonna change the other one. But then I think I have to create another group, and yeah. So let me think about it. Let me do the transistor first. So I think I'm not gonna do the input for the voltage because it's just gonna complicate things too much. So I just represent in the most simple way that I can, which is just 3 nodes that are gonna have the colors. So maybe it's worth to... And the thing is that I'm gonna have to think about this stuff now, I think, to create these graphs. So the main challenges is the events and the animation. So I'm gonna have to think about these things. But I'll be right back. I think if I create a graph that is gonna be too different than the other ones, then it's worth to just copy the component that I have so far and just do like change the names and everything, which is gonna be a lot of work, but it's kind of easy work because I don't have to think anyway. Just have to change everything, refactor, but I think if the graphs are gonna be similar, then it's worth to do like the same template for each one because it's not gonna change much. I think the main thing that is gonna change is the events. So I think I have to think about that, and then the animation, like the events and the animations. But then I can put the logic outside and just pass the functions as props. So I think I'm not gonna pass only a function. I was thinking about passing an object instead. And then the object contains the function, but it then contains more information. Because I'm gonna have to see like if it's gonna change the camera or not. And here it seems like it's a little weird as well. It's not 100% going to the... Maybe it's just like it's light thing, it doesn't matter that much. Yeah, but obviously what I'm thinking about is just using the same logic that I'm using now for navigating to the nodes, but then instead of making based on the key, I just make it programmatically based on the animation. Actually, it's probably better to pass as paths. The hard thing is that I don't know what kind of animations I'm gonna do. Like, I have an idea now, which is just the main idea that I have is just the execution of the thing. So it would be very nice if I could create something that goes node by node, following the execution of the script and highlighting the nodes. I think that would be awesome. But then the problem is if I have other kinds of visualization, for example, let's say I want to jump from nodes, but I guess it's always going to be based on the path of nodes that I pass. So I can pass like an array with the IDs of nodes and edges, and then based on those IDs, I can decide what's going to happen. But the issue that I was thinking is that, let's say I have a visualization that has different numbers of nodes and edges. So how I'm gonna structure the steps of the animation. I think that's the challenge. And I think it doesn't make sense to make the function based on the component inside of the component, because then it's not flexible enough to handle all the... It's pretty much a question of the gradient of flexibility that I'm gonna need. The more flexible the visualizations are, like the animations are for each situation, the more incentivized I am to put the logic outside of the component. And the more they're going to be the same, the more I'm incentivized to put them inside of the component. And I think that the answer is always going to be somewhere along the middle, which is the distribution of information in space-time. So I need to find what the middle way is. I think it's passing a data structure and then passing the function, but then how they structure the function. That's the question. I need to think about a good way to start, like a good step, so I don't overcomplicate things and I can like incrementally try to solve. The other thing that I just remembered is that I need to pass other stuff that I'm initializing on the build graph. Just radius, mass. I think the events are gonna change less than the animation is. I think the animation is very volatile because it really depends on the circumstances. But the events are probably gonna be very similar. So maybe instead of setting the events outside, I just set them as like fixed options. So for example, I can pass, instead of passing the events, I pass flag variables. So I pass an object that contains like the information of which events are gonna... I think that's actually a much better way. Now that I think about it, it makes a lot of sense. And I think this is a pattern that happens all the time in programming. I think especially on React, that you have this trade-off of flexibility with stability, let's say. So every time you create a component, it's like you're creating a template. And because you're creating a template, it makes things more rigid. So the structure of the code is going to depend on the flow of information, the variance of information, which depends on the thing you're trying to do. And the essence of the application is always going to be in the middle way because it's a multifractal object. So it's going to depend on the nuance of the data on space-time that is going to shape the structure of the code, which is going to be the balance between stability and flexibility on the structure of the components. So the hierarchy of the tree of the React components is going to be directly correlated with the variance of data. And I think this is the same thing that is happening here, because I have the component, the graph component, which is a template. And the reason why I decided to do it as a template, because I thought that because it's going to be something very hard to do, very complex, it's better if I just like do it once and then don't have to think about it anymore. And I think that's how most people do these kinds of things. And this is a pattern because I think that it is related to the Occam's razor, energy efficiency, the path of least resistance. And I think that this is directly correlated with the multifractal structure, because the multifractal structure of gravity is just... Gravity creates the multifractal structure because of Occam's razor. So the patterns become the same to a certain extent to save energy, because then you can do the same thing each time. But the problem is that there is always variance on the universe, because the universe is the middle way between the flexibility and instability. And that's the fluctuation, like the flow of information. So it's always the relationship between entropy and information, which is the passage of time. So because of that, each thing that you're going to build is going to be a distribution along the gradient, which is going to depend on the environment. And because the environment changes all the time, the code is going to change all the time to reflect the variation of the environment. Or the code has to be structured in such a way that as it scales, it gets to the optimal gradient of the distribution, where like you have a bunch of patterns that are repeated to save energy and time, to not do the same thing all the time, but at the same time it's not too fixed into one structure, and then you can't handle the new ways that things are going to evolve too as time changes. So I think realizing that now, I'm just like realizing that it's probably better to make the events more stable, because they're not going to change that much. And even if they do, it's not going to be like so high that it's going to be worth it to create a single event for each one. So the events that I can think about is like dragging events. So the ability to drag the nodes around. Making something happen when the node gets clicked, or on the edge gets clicked, or when the label gets clicked, which is always going to be the same thing. What's going to happen is going to be different. That's the thing though, and that's the question. It's like, is the thing that I want the event to do going to change a lot, or is it always going to be the same? So the question is, based on the variance that I'm going to have on what I want the event to do in relationship to that thing, then it's going to determine if it's better or not to put it inside of the component or outside. So one approach is to create the functions inside of the component, which is just putting them here. Then I set up like a template functions for the events, and then I pass flag variables as props, and then based on the flag variables I select what's gonna happen inside of the events for each one. So I can have a template for a drag event, for example, and then I can pass a prop. There is a flag variable that determines whether or not the drag event's gonna be enabled. And if it isn't, then I can have other options. But then the question is on the click event, because the difference is the levels at which the variance is going to happen. On the click event, the variance is going to happen inside of the function, not the event itself. Because the event's always going to be the same, but then the difference is going to be what happens after you click the node. So the flag variable in that situation would be to determine what happens when you click the node. But I think in both situations it's probably better to just create a template for the events. And then I pass the customization as props, because then I can just create more options if I want. And it's not going to be that many. It's probably going to be up to 10 or nothing more than that. But I think the animations is far more like difficult to predict, and I think it's going to be higher variance, because there's so many things that you can do with visualizations. That's like you can essentially create a whole like story with visualization. So I think that there's infinite potential of different variations of things you can do. So it's probably far more likely that it's better to separate and to make it based on a function that decides what's going to happen outside of the component. But I also think that there's a middle ground there, because maybe the structure of the visualization is always the same, which is navigating nodes and edges and changing their properties at each frame. So I think the key to know which path is the best is to understand how to structure the frames. I think that's the main thing. Because on the visualization is based on the delta that comes from reactor fiber, and the delta is the time that they not sure if cache is the right way to put it, but like the time step of each request animation frame from reactor fiber. So and that time is too fast. That's the thing. Like I can't make it based on that time. Because then the visualizations are just gonna be instantaneous. Like it's not gonna be good. So it would be better. Like I need to figure out a way to. I think this is the question: how to select a fixed time for the steps of the visualization. So for example, 2 seconds for each frame, let's say, but not on the request animation frame, like on the instead of basing. Because the thing that I don't want to do is to make the time based on the delta, because then there's going to be a lot of variation. I want the time to be fixed. I think that's the problem. But I guess I can like put a value outside here that uses the now, performance now, I think. And then I can make the calculation based on that. But I think that it doesn't sound like it is the best as well, because then I have to think about the React state. I think the ideal situation is if I can select how much time is going to happen for each event. So for example, like let's say I want to turn this node from green to red. I want to do that in a fixed amount of time. So for example, 2 seconds. Then I turn this edge from white to red, and the node from green to red in 2 seconds. Then the next frame, which is the other 2 seconds, I would turn this back to their previous color, and then turn the next one into red and red as well. And that would like give the feeling of the thing like executing. And I think one of the biggest problems is like this thing about how I'm gonna revert. But the other thing that I realize is that the way that I'm gonna do it is by changing the mesh on Three.js. I'm not gonna change the property of the node. So initially I thought that I would have to put 2 different properties on the node object, one to hold the original color and the other one to hold the new color. But now I realize that like I can have the original color as the initial property of the node, which would be this color here. And then all I have to do is just create a new attribute for a new color. And then I swap between the two because the color that is going to change is the one that is on the mesh. So this color is not going to change when I update the color, and then I can revert back. But I guess this is the fundamental thing, because like what I'm gonna have to do is cache the nodes. That's the problem. Like, but if I do it based on an array, I can access based on the index. But then I have to, like, it's kind of annoying. Because at each frame, I'm gonna have to decide what happens with the middle node and the previous node and the other node. So I can do it based on the index, and then I have to put flag variables or conditions to decide if it's on the end or the beginning of the string or the array. So I guess the time is the main thing. And the question that I'm trying to figure out is whether or not, like, because I can pass this, the way that I'm thinking about it, I was like gonna pass here as animation. And this is like an object that contains the function. So let's say animation would be something like this. It would be an object, then inside of and then animate would be a function, and then like, so I'm passing the function as props, and then I'm calling the function here. Oh, this is another thing that I have to think about, because I'm using these flag variables to see if the physics is enabled. So I guess I would do it outside, because I wanna run the animation regardless of whether or not the physics is enabled. So I have to do the mounted again here, I think. Then I would do animation.animated. And here I would pass always the same arguments, which probably be the nodes and edges. And then the camera. And then obviously I would create this function outside of here, like somewhere here on these files. And then inside of the function I would decide what happens with the nodes at each thing. But the problem is that if I do it like this, then at each delta is gonna change, like it's gonna run everything. And obviously that's not what I want to do. So the question is, how do I structure the function in such a way? Like, the other option would be to, instead of passing the function, I create the logic here. But I think that doesn't seem to be the best, because of the reasons that I just talked about. So for example, instead of passing the function, I could pass in here like the path, like node path and edge path. And this would contain the IDs of the nodes and edges that are going to change. And then I can structure the logic based on the IDs. But the problem with that is obviously that the animation would always have to be the same. And so I think that's not the best. So I guess the question is, how do I pass it as a function, and how inside of the function I select like the time stop. And obviously I can try to do it with set time interval or set timeout or something like that. So I'd pass like another time here, like timer. Then inside of the animated function, I'll put everything based on a set timeout or something like that. But I think that, not sure if that's the best. I'll put the timer. And then here would be the logic. So I guess this is the question. I think I just have to think about, because like I have to think about good ways to. I think I'm gonna use ChatGPT and the search engines. So I have to think about a good way to structure the question, because I think that's not gonna have like anything, because it's nuanced. So I have to think about questions that break down the problem into the small parts. So like the thing like is that I can see several different paths to solve, but the problem is like which one is the best way that's gonna scale the best. So like you can think about asking questions about the delta and how I can use performance now. I think is a library from JavaScript to track the time, and then based on this time. But the problem is this, is that I would have to use Memo, I think, or something like that, because of React state, to make sure that this is always the same time. Or I can use like an integer underneath this, and then I can do it based on the integer. And the integer would be the time, so I just increase the time. Base. Yeah, but this is the problem, because I think I have to make it based on the delta. But I want to try to avoid that. Because if I make based on the delta, then the animation is not going to be reliable. And that's not very good. Because ideally would be able to have the same animation each time. And also because I want to create the input that is going to change the properties of the animation. But this is another thing that I didn't think about. Yeah, this timer here would have to be dependent on the store. So I need the timer and the step. The other question is whether or not I use the same store that I was using for the other components. I think I'm gonna do that. And the only thing that I'm gonna use the same store, but then I'm just gonna create a like other HTML to create the component, because the way that I'm envisioning is more in the bottom here. I think it makes a lot more sense. In the same way that a playlist works. So you would have the step for back and forth, and an input that determines like how fast the thing is going. So just like watching a video. And that's the thing that I want to try to achieve. So I think I'm gonna make it based on the same store, and then, but the problem with making based on the same store is whether if I want to create other types of graphs, then and I don't want to show these components, then it would be good for them to be decoupled from each other, because then I can just reuse this one. And the way that I was thinking about it is, I think like I don't see why I wouldn't have this one all the time, because it's just like it's very useful and you can hide here, so like it's not gonna hurt any of the visualizations, I think. So I was thinking about, but I can make a flag variable that determines whether or not the other component is gonna show up, because the other one might not be useful for some kinds of visualization. And the reason why I don't want to put here, like as part of these options here, this component, is because then it's not intuitive for someone that is using, because they're not gonna know that they can like visualize animations. It's much better to put it here and should work kind of like in the same way that the videos work. I think it's a lot more intuitive. And this is the problem, because there's so many different types of things, I think. Different types of customization that it would be nice to have. So like it might be the case that in the future I have other components that I want to do. This is the problem, is like how do you scale this so that it doesn't become a huge mess like later on. That's the problem. Because if I make it based on the flag variable to show and then separate, create another store, then separate. I think that's what I have to do actually. I have to create another store. It's much more organized to have like each thing for each customization. But then the problem is I have to pass like flag variables, I think, to indicate which ones I wanna use. That's very annoying. 'Cause the problem is that the other ones are wrapped inside of these ones. So like I would have to put a ternary here that depends on the prompts that I receive here. Let's say main customization. And then I load this stuff, but the problem is that the other stuff is like under this one. One of the issues as well is that I have to put the customization components inside of this other, the graph component, because otherwise I'm not gonna have access to the nodes and edges because of the way that I'm doing the store here, which is from the using dependency injection from the Zustand documentation. And the reason why I'm doing like this, I still have questions about this, whether or not it works, but the reason why I'm doing like this is that it looks like if you do it like this, where you create the store like here, then if I want to reuse the graph component and multiple different parts of the website, one graph is not going to interfere with the other. So the main problem is the store, because if you have the same store and you initialize the store outside of the component, then if you have two different graphs components at the same time, if you change the value of one store, it's going to change the value of both graphs at the same time, and obviously that's not what I want. So the thing is, I haven't tested this, so yeah. Maybe I should test this before, like load two different graphs on the same page and see. Yeah, if I test and fails, I think I'm not gonna do everything again. I'm just gonna do other components then. You just do one type of graph for each type of visualization. Because this is only important, I think, when you have two different graphs in the same page. So obviously when you leave the page, it's gonna just... I have to like set the nodes and edges to empty when it leaves the page, and then the other ones. But it is problematic because of the state of the store, the state of the website. Because if I have users, I also want to have the ability to allow people to like maintain the state of the website based on the local storage. And it's gonna be very complex when I get to that point. I think it doesn't matter that much to have, like, it's not gonna save a bunch of time if I like load the provider each time. I can make the flag variables inside of here, and then it's a lot easier because this is the customization component. So even though the store is not gonna like show up, it still exists on the background, and I think that doesn't matter that much. So I think I'm gonna create another store and then create like similar to what I did here with this one. Trying to think what is the best, like, what should I do first? I want to break everything down, so I work on the simplest thing first. Maybe I should test the graph thing first. So I just go in the component that I'm working now, and I'm gonna remove or comment out this stuff here, and then I just put two different graphs here. Just see what happens. But I'll be right back. And I'm gonna do this. Once I have this, then once I test this, then I decide. If one graph fucks up the other one, then I just create another graph. And then I just create each, like I just copy everything in Refactor and create a template of a graph for each type of visualization that I want to do. because I think that's going to be better than having to rethink everything and trying to figure out a way to make dependency injection works. Because I think it's a more fundamental problem with the way React works. It's a problem with the context itself, I think, and I'm not pretty sure if there's a solution if this one doesn't work, which is that if you want to select the scope of the context, like limit the scope of the context for only one part of the tree. I'll be right back. So let me think. Oh, I guess the thing that changes as well is which nodes and edges I'm gonna use. But I think like one on a situation, I would use different nodes and edges for each thing. In a situation where I wanna have two different graphs on the same page, I'm gonna use two different nodes and edges as well, I think. Thinking about what is the easiest way to. I want to create two different. I don't want to think too much, so I just want to create two different nodes and edges that are very simple. I don't like that much this ID here for the edge. Just feels like very bad to do it like this. So I need to think about a better way. The thing is, I don't think I use the edge ID for anything. The only thing that matters is the source and target. This is another problem, which is that I'm using Graphology, so like later on I would like to change the nodes data structure and maybe the edge data structure as well, so that it doesn't take the ID of the node, it takes the node itself. Yeah, I think the edge is fine, but then change the node. I think I'm gonna have to separate them with a div. Yeah, it looks like something is wrong as well. Yeah, here. Yeah, so this sucks. Looks like it didn't work. The star is working, but something else is wrong. Maybe just because I... We'll say that it does work. It's just because I'm saving. This is a problem though, because of the coordinates. It's annoying. And here... Oh no, it's working. And this is obviously like the mistake that I made here. The issue is that the way that I did this function is just by getting the stuff that they were doing in the other one. So I assume that the problem is this thing here. I think maybe if I change for offset instead of the client X, but I'm not really sure if offset has a problem because of CSS. So, like the way that it's gonna work on different pages. Not sure if the offsets. I think usually they recommend to use client X and Y. But I think this is the thing that is fucking up there. They're dragging, but I think it's not a big deal. I think like I just wanted to test to see if you would create two different graphs and if the events of one, like if the start of one graph wouldn't fuck up the other one. And I think it doesn't, so. Yeah, this one still works. If I change here, it doesn't change the other one. So I think I was gonna put them on different divs and see them, but I think I will worry about this stuff later. I'm gonna focus on getting one graph right first, then I think about the rest. I think the stuff that I'm thinking about, obviously it is important and like it is related to this thing because it's the way that the thing is gonna scale, so. But I think as long as I think about that, then later on it's not gonna be that hard to make the coordinates work. I'm probably just gonna have to change like a small detail on the function itself. But I think what I'm gonna do for the events is just create the templates for what the events are gonna do. And then I pass props that determine based on flag variables which events are activated and which ones aren't. And I think that I'm gonna do based on the store values instead of making, like I'm gonna pass as props and then from the props that I pass I'm gonna set the store values to be equivalent to the props, so that way I can manage the events based on the store, because then it allows me to put an input on here that determines whether or not the person can select with what's gonna happen when they click the node, because I think that is gonna be very useful. So in some situations you want to drag the node and then you can turn that off and put the other on, which makes another event trigger when you click the node, which would be you should navigate through another page or something like that. This is another idea that I have like some time ago, which is just three-dimensional search engine. And I think that people thought about this probably, but the reason why they probably don't want to do it is because like transparency. That would be my guess, but I think that would be a very nice thing. So for example, in YouTube, if instead of searching for the videos based on the recommendation algorithm, they searched a probability space of graphs and their connections. But then the problem with that is that it would allow people to see how the recommendation system works, and it would take their power away. I think that's the reason why they don't do it like that. Because a lot of the times it's much better, like on YouTube, like a lot of times I watch videos that I'm not even that interested on, but it is what it keeps recommending me, and it's probably because of the algorithm. So like a three-dimensional search space would be a lot better, I think. And it would allow for a lot more variations of search. I think I'm gonna focus on the animation before the events, because I think animation is harder. For the events, what I'm thinking about doing is just the standard ones, and then because I can't set the event directly on the mesh, I think I have to set on a DOM element. What I'm gonna do is just inside of the function, I grab each thing in a separate way with the raycasters. So I separate the meshes based on the raycasters, and then for each mesh, inside of the functions themselves, I put what's gonna happen for each one, and it's gonna be based on options. So like you can see a path is not that hard, but the animations is still, it's very confusing for me. Like how do I select the order? I think the main thing that I have to figure out is the thing about the use frame. So that's what I'm gonna think about now. I think probably the best thing to do is to just like create a basic, like create the graphs first, then I think about this later. So I'm gonna search for the transistor. Should remember like what are the. I think there's a nice video from Veritas. Not sure if I'm saying it correctly, where he talks about that. So a silicon phosphate. I think I'm just gonna do the simplest representation, but I have to think about how I'm gonna do it so that, because it would be nice to display like the mechanism. How can I do that? Maybe I can do it based on colors. So I represent on the gradient of colors. I'm trying to think about a way that I can represent without putting the... But either way, I'm gonna have to either figure out the animation or the events to display the transistor being turned on and off. And I'm gonna have to create a DOM element that represents... this is the problem. Like, I think this is a very big problem actually. Like the biggest issue is that anything that I want to do with a DOM element to represent something about the visualization, I have to put inside of the graph. I think this is the biggest problem. It's like a kind of like a paradox, because the way that I set up things is so that each graph is encapsulated in their own store. Like the store has a closed scope inside of the tree, so I can create multiple different graphs with the same store. But the issue with that is that if I wanna, everything that I wanna create as a DOM element outside of the graph, it has to be inside of the component, so it has access to the nodes and edges. And this is the challenge, because here, for example, I was thinking about, like, one thing that I thought about is create something like an IDE, but instead of allowing user input, I would just like highlight the line that the command's being executed, and then highlight on the graph. But if I want to do like that, then I have to create a component that is going to have the code, and that component is going to be inside of the graph. But if the component is inside of the graph, then I have to create a prop that is going to determine whether or not the component is going to load, because obviously I wouldn't want to load the same component for each visualization. So, but I don't see like a very good way, because if I build outside, then how I'm gonna access the nodes and edges? I guess I can make the bridge based on the state of React. So reload the graph each time. I guess that's probably the best way. So for like the nodes I'm passing outside of the component, I change those nodes, and because those nodes change, then the graph is going to change as a byproduct. But the problem with that is that it's going to have to reload the graph each time there is a change, which is not very efficient. So the question is, how do I decouple the DOM elements with the visualization? I think the only solution that makes sense in my mind right now is this one of the, like, like the way that I do it is by changing these nodes and edges here, and then when I change these ones, you remounts the mounts again the component, and then it changes everything else. I think that's the only way. Otherwise, I'm gonna have to keep like adding a bunch of garbage inside of this component that is gonna be a bunch of DOM elements that are unrelated to a bunch of different visualizations. It's not efficient. It's not good. But I think that yeah, I'm gonna try to reach that balance because it's obviously gonna be the gradient again, like I said. So I think some of the customization components I do it inside because the speed matters. So I think that the animation component is gonna be inside of this one. So I have to create a props that is gonna be the animation, and it's gonna be an object. The animation. Let me think about it. Maybe it's better to create the graph first. I'm gonna focus on creating the graph, then like, I'm gonna create simple, like these three ones probably, like the transistor one first, and then two logic gates ones. Then after I create the graph and I put them on the page, then I think about it, which one I'm gonna do first. I think I'm gonna try to do the animation first. Then I think it's better probably to set up the animation function, and then based on the animation function, I set up the variables on the store that are gonna regulate everything. Yeah, the question, I'm gonna write down this question, then I'll go grab more tea. Then I'll come back, watch the video, build the graph. I think I'm just gonna build the graphs, see the visualizations, then think about later. Like I'm gonna stop streaming and then think about this off stream. There's a lot of other stuff that I have to study as well, so. I think I need to add the timer on the store. So I have to think about how I'm gonna structure this on the. Well, actually, I'm gonna create another store. Yeah, I'm gonna create another store. I think for this one is worth it. And then for the other stuff, I'm gonna do like I said before, where I'm gonna change the nodes and edges outside, and then it's just gonna remount the graph each time. But I have to think about that more as well. Because the issue with that is that if I'm trying to do, yeah, I think for the animations, like, it's very bad if it mounts and mounts. But if I'm trying to step over or something like that, like create kind of like a debugger, then I also think that it's very bad if the graph mounts and mounts each time, because then it's not gonna show like the visualization of things. It's just gonna reload the graph each time. But the other thing that I forgot is that it's probably better to initialize the physics as off in the beginning, and then turn them on uh, later when the user clicks the thing. Maybe not. Maybe I was thinking that I thought about this because I thought it might be better on some like visualizations if the physics is off first, but I think it's probably better to leave us like this. Yeah, I have to do the animations first, and I'll, I'll see this with time. I think which one is better, but I think that this one makes sense. Maybe it's better to pass as a prompts, and then I make the value based on the star. Yeah, I pass a condition as props, and then I make the condition based on that value. So I accept here, and then if it is true, then it's true. Because in some situations, for example, I think like if I create a layout, for example, in the future that shows, I think this is the reason why I was thinking about this. Because if I'm gonna create the 8-bit computer, then it would be nice if I could think about a layout that structures the visualization in a way that makes sense to understand what's going on the computer. And if that's the case, then obviously it's better if the physics is disabled first. But then it's better if it's disabled on other ones. So I think it has to be dependent on props. But I'll think about this later. I think I'm gonna focus on the other stuff first. So I'll be right back. I'm gonna create 3 simple graphs, then visualize them there, like see if it works. I have to do the fetch request to get the graph, then structure the nodes and edges and set the graph components. Then I think I'm gonna stop streaming and I'm gonna think about the other stuff after. I just streamed today because it has been a long time since I haven't streamed. And I'm probably gonna not stream for a long time as well because I have to. The other course that I'm doing about the operational system is 25 hours, like more than 25 hours long. So I have to finish that course, and I'm also like studying assembly as well. So I'm watching like already watched a bunch of different videos about assembly. So I want to do study these things as I think about this stuff here, because like these decisions that I'm contemplating about today, I think are very important and very hard to figure out like what's the best path to go. So I think I need to handle this when the component amounts. Yeah. But maybe it doesn't matter that much.
In this phone, there are nearly 100 million transistors. In this computer, there's over a billion. The transistor is in virtually every electronic device we use. TVs, radios, Tamagotchis. How does it work? Well, the basic principle is actually incredibly simple. It works just like this switch. So it controls the flow of electric current. It can be off, so you can call that the 0 state, or it could be on, the 1 state. And this is how all of our information is now stored and processed in zeros and ones, little bits of electric current. But unlike this switch, a transistor doesn't have any moving parts, and it also doesn't require a human controller. Furthermore, it can be switched on and off much more quickly than I can flick this switch. And finally, and most importantly, it is incredibly tiny. Well, this is electric current better than insulators, but not as well as metals. This is because an atom of silicon has 4 electrons in its outermost or valence shell. This allows it to form bonds with its 4 nearest neighbors. So it forms.
If I really want to go crazy, then I can do the molecules as well. So I can do a graph. This is actually another very interesting idea, but maybe I'll do that in the future. But I think that's a very interesting idea actually. So I can model everything as composable graphs, and then I can create different types of structures based on the graphs. I think that's a very interesting thought. So I can create algorithms that put everything together. I want to be careful to not like deviate too much from the thing. The hardest part now is figuring out, like, clarifying the distinction between the compiler and what I'm trying to do. I think once I'm done with these visualizations that I have now, yeah, once I figure out the problem is that there's still these nuances here as well about the links and everything. But I think the two main things are the events and the animation. Once I figure that out, then I think it's probably better to just create, like, forget about what I'm trying to do, just create a parser. Then based on the parser, I create the visualizations after. I think that like the more I do that, the more the easier it's gonna be. Then I think about the other stuff. Otherwise, I'm just gonna be going paralysis by analysis.
A tetrahedral crystal. But since all these electrons are stuck in bonds, few ever get enough energy to escape their bonds and travel through the lattice. So having a small number of mobile charges is what makes silicon a semiconductor. Now this wouldn't be all that useful without a semiconductor's secret weapon, doping. You've probably heard of doping. It's when you inject a foreign substance in order to improve performance. Yeah, it's actually just like that, except on the atomic level. There are 2 types of doping, called N-type and P-type. To make N-type semiconductor, you take pure silicon and inject a small amount of an element with 5 valence electrons, like phosphorus. This is useful because phosphorus is similar enough to silicon that it can fit into the lattice, but it brings with it an extra electron. So this means now the semiconductor has more mobile charges, and so it conducts current better. In P-type doping, an element with only 3 valence electrons is added to the lattice, like boron. Now this creates a hole, a place where there should be an electron, but there isn't. But this still increases the conductivity of the semiconductor because electrons can move, and so it conducts current better. In P-type atomic level, there are 2 types of doping, called N-type and P-type. To make N-type semiconductor, you take pure silicon and inject a small amount of an element with 5 valence electrons, like phosphorus. This is useful because phosphorus is similar enough to
Not sure how that's how
silicon that can fit into the lattice, but it brings with it an extra electron. So this means now the semiconductor has more mobile charges, and so
No.
So it conducts current better. In p-type doping, an element with only 3 valence electrons is added to the lattice, like boron. Now this creates a hole, a place where there should be an electron, but there isn't. But this still increases the conductivity of the semiconductor because electrons can move into it. Now, although it's the electrons that are moving, we like to talk about the holes moving around because there's far fewer of them. Now, since the hole is the lack of an electron, it actually acts as a positive charge. And this is why p-type semiconductor is actually called p-type. The P stands for positive. It's positive charges, these holes, which are moving and conducting the current. Now, it's a common misconception that n-type semiconductors are negatively charged and p-type semiconductors are positively charged. That's not true. They are both neutral because they have the same number of electrons and protons inside them. The n and the p actually just refer to the sign of charge that can move within them. So in n-type, it's negative electrons which can move, and in p-type, it's a positive hole that moves. But they're both neutral. A transistor is made with both n-type and p-type semiconductors. A common configuration has n on the ends with p in the middle. Just like a switch, a transistor has an electrical contact at each end, and these are called the source and the drain. But instead of a mechanical switch, there is a third electrical contact called the gate, which is insulated from the semiconductor by an oxide layer. When a transistor is made, the n and p types don't keep to themselves. Electrons actually diffuse from the n type, where there are more of them, into the p type to fill the holes. This creates something called the depletion layer. What's been depleted? Charges that can move. There are no more free electrons in the n type. Why? Because they fill the holes in p type. Now this makes the p type negative thanks to the added electrons. And this is important because the p type will now repel any electrons that try to come across from the n type. So the depletion layer actually acts as a barrier, preventing the flow of electric current through the transistor. So right now the transistor is off. It's like an open switch. It's in the zero state. To turn it on, you have to apply a small positive voltage to the gate. This attracts the electrons over and overcomes that repulsion from the depletion layer. It actually shrinks the depletion layer so the electrons can move through and form a conducting channel. So the transistor is now on. It's in the one state. This is remarkable because just by exploiting the properties of a crystal, we've been able to create a switch that doesn't have any moving parts that can be turned on and off very quickly just with a voltage. And most importantly, it can be made tiny. Transistors today are only about 22 nanometers wide, which means they're only about 50 atoms across. But to keep up with Moore's law, they're going to have to keep getting smaller. Moore's law states that every 2 years, the number of transistors on a chip should double. And there is a limit. As those terminals get closer and closer together, quantum effects become important, and electrons can actually tunnel from one side to the other. So you may not be able to make a barrier high enough to stop them from flowing. Now this will be a real problem for the future of transistors, but we'll probably only face that another 10 years down the track. So until then, transistors, the way we know them, are going to keep getting better.
Once you have, let's say, 300 of those qubits, then you have like 2 to the 300 classical bits, which is as many particles as there are in the universe.
The main question that I have is whether or not I think it's not worth. Like, part of me wants to try to do the voltage thing. So like create an input that is gonna change the voltage of the thing, and then it changes the colors of the nodes based on the voltage. I think I'm not gonna do the transistors actually, because it's deviating too much. It's gonna overcomplicate things. Like maybe in the future will be nice. I think for that kind of stuff, it's gonna be nice to have another graph component. Because I just realized now that like this is very powerful as well. Like I can model chemical elements as graph networks. And then obviously it's gonna be different than the way that we think it is because of quantum mechanics, but like I think you can get a decent approximation and then like represent the voltage and of different things on the graph. I think that's interesting, but I think it deviates too much from what I'm trying to do. So I think I'm gonna focus only on the gates, and then just simplify and make based on the labels themselves. And then the complexity is gonna be when you put like all the gates together and displaying the logic of each thing. So I do it based on the gates, then from the gates, like I create a graph that builds the register, and then like on higher levels of the graph, the only thing that is gonna change is the label. Other thing that I'm thinking about right now is like if I do it like that, if it's better to make each thing have its own color to represent like what it is. So for example, I built like on the level of the gates is all the same colors, which is green and red. But when I build like more complex components like a register, then I change the color to represent like to make it easier to understand that is a register. But then I'll have to attach nodes to the register to represent like the inputs that it would have. So it's similar to the way that Ben does it on the computer. I think that would make it easier to understand. Like maybe I'll change the colors of the labels and then just keep the nodes the same. I think that's a good idea. And then I just increase the size of the labels because that makes it easier. Because if I keep everything the same, then it's easier to highlight which thing is gonna be like activated at each time. which makes it easier to visualize the whole thing. And obviously, I'm not really sure if I'm gonna go all the way because I don't have a lot of time, and because I have to study so many other things. So I think I'm gonna stop here. I'm already tired. I'm gonna do this stuff off stream. I'm probably not gonna stream for a long time because I want to finish the other course and I have all this other stuff to study, and I'm gonna do this stuff as well as I study the other stuff. Then I think next time I'm probably gonna. Hopefully, we will already have like a lot of these graphs, and then I'm gonna try to. Maybe next time I'm still not gonna. It depends, obviously, when I stream next time, but I think it's likely that I'm gonna try to figure out the animation, like either figure out or optimize the animation and the events for each thing, and then once I have that done, then the next thing to do is to create a parser in Python, a lexer and a parser in Python, which I think I'm probably gonna take the stuff from C that I have now and try to understand more by looking at the source code and see how I can translate that into Python code and then parse Python files or JavaScript files with the Python interpreter. The thing that is going to change is that the C compiler is done for C. So obviously I'm going to have to change a bunch of things because the syntax is different. And in the process of doing that, I'm going to have to study a bunch of things about Python as well and JavaScript, about the syntax and everything that can happen. And there's a bunch of other stuff to study in relationship to grammar as well and all the other stuff. So yeah, but that's probably what I'm gonna do next. And I'm not really sure when I'm gonna come back. So, but probably soon, like probably in a few days, something like that. So.